Okay, yeah, it thinks it seems it is working. So we do have uh, 5 presentations. It is a Chem 676 course. The goal is to get sufficient basic skills to apply them to practical research and complement your graduate thesis and research work with computational component. And there will be a total of 4 presentations. It is number one, which shows the basic um, mm, practical protocols targeting to build atomic models, because any computational work is related to characterizing the model. And same as in the experiment, there is a synthesis and characterization. Now we are dealing with an analog of synthesis, just building models, set of ions at certain distances that later can be characterized. Um, the goal is to use 5 minutes per talk and finish by 10. After each talk, questions are encouraged, and the philosophy of these presentations is that knowledge sharing between class attendees help all of us to master certain skills. So one person delivers skills in one aspect, and others can complement what they did miss in the labs or lectures. So with this, I call, invite Boston. What I need to be Boston Keyford.
Yep.
I promise by the end of semester for sure all your names first and last. And floor is yours. The presentation will cover uh, Linux remote operations as the fundamental background for any computational work. So floor is yours.
Yep. Does everyone see the screen okay? Just to make sure.
And Boston, please share the camera, because sometimes enable camera, if something doesn't sound well, it's possible to read by lips.
I was going to mention that I don't have a camera on this computer. I did this on my desktop, which doesn't have a webcam.
Okay, but next presentation, I suggest everyone make sure camera is available, or make a second connect through cell phone so that the face is visible.
Okay, yeah, I'll definitely make sure I do that next time then.
Okay.
But can everyone see the screen okay, just to make sure before we get started? Okay. So yeah, this is on basic CCAS and Linux usage. So just to start off with, you might ask, what is CCAS and Linux? Linux is an operating system which is similar to Windows and Mac, and it's essentially how the computer talks to programs and how it does everything it needs to do. It's the language that it does it in. Linux is open source, which means anyone can look at the code and see what Linux is doing under the hood. And it's also typically much faster on servers and supercomputers, which is why it's very popular. I'd be hard pressed to think of any supercomputer that doesn't use Linux. So that's why it's a very popular thing. Someone's in the chat, hold on. Oh, I am using multiple screens. Hold on, is that? So is everything not showing up?
Right now we have the presenter's notes screen. So if you switch which screen you are selecting to share, we should be able to see the presentation.
All right, let's see if I can figure that out. Is that better?
Yes.
Okay, perfect. So as I was saying, yeah, Linux is used on supercomputers and things like that because it's typically much faster. The supercomputers and the organization that we have on the NDSU campus is called CCAS, which stands for Computationally Assisted Science and Technology. And it's a remote Linux-based high-performance computing system. And remote means you can operate it from pretty much anywhere so long as you have access to the internet and the right programs, which we'll talk about in just a second here. But yeah, you can operate it at your home, at college campus if you need to. All you need is to just be able to sign in virtually over your own computer, but then you'll have access to the high performance computing cluster, which you can see, that's not the one we have at NDSU, but it is an example of a high performance computing cluster, which is just a lot of computers essentially just linked into each other to act like one giant one. So to get started, you have to create a CCAST account. And the way you can do that is if you just follow the link I have given here or type in CCAST into Google or something, you'll be able to find their webpage. And all you have to do is click apply for account. You'll be asked to fill out a couple forms. We're talking about you, how you plan to use CCAST and information about your advisor and things like that. And then just wait for a confirmation email that gives you some information about like your username and password and things like that. Your username and password should be the same ones that you use to get on NDSU computers as it already is. So then once you have an account, in order to log into CCAST, you'll use a program such as MOBAXTERM like we've been using in class, or alternatively, CCAST itself recommends the programs PuTTY and Windows, or excuse me, not Windows, WinSCP, which do the same thing as MOBAXTERM, just in a little different kind of format. So whichever pleases your eye more, you can use. And then to log in, it's a little bit different on PuTTY and Windows or WinSCP, but on MOBAXTERM, you can just use the command SSH your username at thunder.ccast.ndsu.edu. And then after usually takes about 30 seconds for it to actually connect to the system. You'll be asked to enter your password. And as I said before, your username and password should be the same as it is for regular computers. For more information on it, you can go to that link, which is the CCAST website. And then once you're in CCAST navigation, or the CCAST screen itself, which you can see an image of here on the right, you navigate it like you would navigate any other Linux-based system, which we'll talk about some of the commands here. So one of the most common commands that you use is the CD command, which is choose directory. And the way you do that is if you just type CD and then your directory file path, you will go to whichever directory that you want to go to. There's some other shortcuts, like if you do CD ... you'll just go one directory up. Or if you do CD/, you'll go to the root directory of whatever server you're in. And then there's some other commands like ls, they'll list all the files and directories that are currently in the directory you're in at the moment. And then pwd will print whatever directory you're actually in. As you can see on the image here, I actually ran pwd to get the directory that I'm in this system. And there are some more basic commands. If you do make dir, you'll create a directory with whatever directory name that you specify. If you type the man command, you'll or man and then a specific command like such as make directory, you'll get a user manual for that command. So it'll teach you how to use that command if you're not familiar with it. History will give you a history of the commands that you've used, and then more will display text that's in a given file that you specify. And then VI, which is an important one, either creates or opens a file with the given file name. And then that link down there will send you to a site that teaches you all about Linux commands. There's a lot of information in it. So if you're interested, you can go to that and learn a lot more about Linux. Then a lot of these commands that I said have options to them, which you just kind of slightly change their functionality. So for example, the VI command that I listed, if you type -R after it, and then the file name, it'll open a file only in read view. So you can't actually change it, which can be useful in some situations when you don't want to actually worry about messing up your text file. And then you can search commands on a search engine to find out more about some of the options they have. There are a lot of different options for many commands. That VI program or the VI editor I talked about, after you use the VI command, you'll be greeted with a screen like this. I have typed a lot of things into this text editor here that are pretty much just repeating what I have on the left. If you type the key I, you'll enter insert mode, which allows you to type in the VI editor. If you push escape twice, you'll go back to the command mode. And then in command mode, you've got these 3 common commands that you can use to either quit without saving, to save, or to quit and save. So those are some basics of VI. Again, to find more specific things, you should look it up and learn a lot more about it, because there's a lot more you can do in the VI editor. And then moving and copying files. If you're in a Linux-based system, if you're using MOBAXTERM, it's pretty easy. There's just a sidebar that lists different directories, and you can navigate through that. And then you can just copy and paste and move things around in there. If you're using commands, those three that I have listed there will move, copy, and then do secure copy in that order. And the way they work is you specify whatever you want to copy or move, and then you specify the destination where you want to send that. And then there's also the deleting a file. If you want to delete a file or a directory, you can just type rm and then specify the file name, and it'll delete whatever you're working on. And so it's pretty much all that I have. I probably went over time. Yeah, so, but
okay,
yeah.
join me thanking Boston. And quick questions will be appreciated. We still have maybe a little time. Use your chance, and Boston should be responsible for what he presented. If you wanted to learn more about use of VI command or things like that, use your chance to ask. Quick question.
Yep.
You mentioned PuTTY, MOBAXTERM. So what they are, how they differ, what do you prefer?
Yep. So I've actually been using PuTTY a lot more than I have been MOBAXTERM, just because when you use PuTTY, I actually like MOBAXTERM more than PuTTY in just the like interface. So like, where's a good picture of it? Right here. You get a very similar interface like this in both MOBAXTERM and PuTTY. But what you get differently between the two of them is the Windows, or I always say Windows, it's the WinSCP program, which is similar to the sidebar that I showed here, except it also lists the all the files and directories on your local computer as well. So you can see them both side by side, so you can transfer them really easily in that WinSCP program. So I like using that just because I feel it's a little bit more intuitive for me. But the functionalities between just the single MOBAXTERM and the PuTTY plus the WinSCP are very similar. So
okay.
It's just a matter of personal preference.
Perfect. Thank you. More questions? 1, 2, 3. No questions. Let's thank Boston once again. Let's, Lina, please start sharing your screen, and Boston, stop sharing the screen. So the next presenter is Lina Ahmad Al-Hahoui. I hope I pronounced it correctly. So, and she will teach us more about file transfer and building molecular models with Gauss view, which is a key tool for next at least month. So, floor is yours.
Yeah, good morning, everyone. So in my presentation, my outline would be two main points. So first, how to upload and download files to or from the supercomputer, and then building atomic models using the visualization software Gauss View. So here's starting by working with the files. Prior to that, I'll just remind you, first, we need to remote login. So I think Boston did great work in explaining how to log in and some necessary commands to choose the directory. So here, remote login, as Boston mentioned, using the commands SSH and your username on the for your account at the host name. So for example, the host name that we usually use in the class, it's photon.chem.ndsu.edu. And then to choose the directory, we need important commands like ls, list the contents of directory. You need to see what's the files that you have in that directory. And if you want to change the directory, you use cd. And this is the example for a cd command. You will choose the files that you need to go to work on. And if you need to check that what's the directory you are working on, you can use pwd. And then if you are familiar with these commands, you will be ready to to use the commands for uploading or downloading. So it's just simply SCP, and then you organize the file name and your username at the IP address or the host name for your supercomputer. And for uploading, we use this command, and downloading this command. So uploading, which means that you want to upload the file from the supercomputer to your from your local computer to the supercomputer. Downloading is the opposite for that. So if you are familiar with these commands, also it's you can go and try to build atomic model using another using visualization software, as I said. So here, to build atomic models, you need first to know how to run Gauss view, and then we will talk about. I will talk about what's the functions that we can do for building the models that you need to obtain. So first, running Gauss view, we have this command. I think we are familiar now with this command, and then if you use this command on the, you will get these windows. And these windows, we have some windows like control panel, which has some the important bar, the menu bar, and toolbars that you need. And then so like that, you are running the Gauss view, and the next step, like how to build the atomic model. As you can see, we have, sorry, we can here from the file menu bar, you can open the window for viewing your model, and there's two other windows. You can choose which function you want to use, but first you have to choose the elements. So this is briefly how it works, and then the periodic table has all the elements and the valence you want to work with. And here in more details, so building the atomic models. So the first step would be selecting the element and valence. So as you see the arrow for this function, you can see if you press this button, you will be able to choose which element you're gonna use, and also here you can use the valence that you want to build, like the molecule that you want to visualize. So here, for example, if I choose the atom, the carbon atom, I will see this this molecule. It's the methane, I think. I built a carbon atom with 4 bonds of hydrogen. So this is my molecule now. So next step, okay. So next step, if I need to modify like the distance of the bond between 2 atoms, it's simply I choose this function here and press this button. You will be able to choose 2 atoms. So here, for example, I choose the carbon atom and 1 hydrogen atom. So I decided which 2 molecules I want to modify the distance, the bond distance between them. So, well, when you just decided which atoms you want to change the bond type for, like here, single bond or I forgot what's the name of these bonds, but and then for this scale, you can change the length of the bond. So in this window here, I increase the length so you can see how it's changing. So depending on your model, you can decide and you can modify the distance between the bonds between any atoms you want to work on. So this is the first task I want to explain, and then we can also modify the angle between the atoms, and this option here give us the opportunity to control the angle between 3 atoms. So here I choose these 3 atoms. So when you press this button, you can choose the 3 atoms. So I choose 1 hydrogen and the carbon atom and the other hydrogen here. So here also, whenever you choose these 3 atoms, which any 3 atoms you want, you will see again this window. And after that, you can control, for example, here we have 3 options also for the atoms, like atom 1, atom 2, and atom 3. You can fix some atoms or rotate the group or rotate just add 1 atom. So depends, so you can control like how the motion would be until you adjust the angle that you want. And after deciding like how the atoms would be changing or fixed, you can just change the scale here. And as you can see, I could do like I could change the angle between these 3 to be like this. So again, depends on your model, you can decide. So the most important thing to be familiar with the functions and how to use which options that you need to be able to get the correct or the desired model. So finally, I have the here dihedral angle, which means if you want to adjust the angle between 4 atoms here. So again, we have another option. So far, we worked with the distance between 2 atoms, angle between 3 atoms, and then press this button, we will be able to adjust how the shape between 4 atoms. And I choose this model now because I need like a structure to be able to choose 4 atoms. Then I choose these 1, 2, 3 carbon atoms and 1 hydrogen here. And pressing that button in the screen, again, you will see the window for adjusting and modifying the dihedral angle. Again, the same thing, you have like, you can control the atoms, like if they are fixed or which one to rotate, and then to change the scale for the direction of the angle and the magnitude of the angle to get the desired shape. So this is all of what I want to present for today. So it's clear that we need to be first familiar with the commands that reach you, the good directory to choose the file that you want to work on. And then if you want to build an atomic model, you can easily like save your file in your account, and that's it. So
okay, please join me in thanking Lina for useful instructions. Any questions? Please feel free to ask. And plan for future talks and future presentations. Please plan to develop your questions. It's really help speaker. And some questions are not only way to torture the speaker, but way to show appreciation that you do care of what speaker is talking. So I have a tricky question which you may or may not have an answer. If you need to build a polymer that consists of repeating units, would you identify any tools in Gauss view that allow for making cut and paste operation to reproduce the same fragment again and again?
To produce the same fragment, you mean if I want to repeat this?
Yes.
Yeah, it's just simply after selecting the atoms and the bonds and everything, you just click on the window anywhere you want to repeat the model, and you will get similar model when just to click on the screen.
Okay. Yeah. Thank you. More questions?
So just the clicking here or there, you will get the same model.
Okay.
The same atoms or molecule that you built already.
More questions to Lina?
Well, I have.
Yes, Javed, please.
It's not actually a question, it's just addition of your comment as you just said. So there have another feature in Gauss view. You can go to the edit and then go to the options called PBC, is for periodic boundary conditions. And you can use that to make a long periodic unit. You can add it one by one, then how many ever you want. So that will keep all parameters consistent. And I would like to tell you that another keyword for Gauss view is very helpful. Sometimes we need to move the fragment of the molecule, not whole molecule. In that case, you can use the like Shift Alter, and then you can move your mouse and then you can see the changes. And also they have another shortcut for caps lock Alter. And then if you move your mouse, only one fragment will move around. So that's, yeah. So that is very helpful when you work on the fragment of the molecule. Yeah.
Thank you, Javed.
Well, it's a very nice presentation. Thank you.
Okay, once again, let's thank Lina once again. And Sarah, Lina, please stop sharing. Sarah, please start sharing.
Yeah. Sure.
So the next presenter is Sarah Gazanfari. Please correct me if I need to improve my pronunciation. And thank you. She will present on two aspects: how to convert formats, files saved in different formats, and how to edit molecular models with different software. Okay, floor is yours.
Hello, everybody. Today I'm going to talk a little bit about two softwares, Avogadro and OpenBubble. The first one is Avogadro. Avogadro is an advanced molecule editor and visualizer designed for cross-platform use in computational chemistry, molecular modeling, bioinformatics, material science, and related areas. It offers flexible, high-quality rendering and powerful plugin architecture. It is free and open source. As you can see in the bottom, it's the interface of the Avogadro. There are several menus, which I'm going to talk a little bit about three of them. The first one, which symbols is like a pencil. It's for drawing a molecule or atoms. In this element menu, you can choose which atom you want to draw. If your atom that you want to draw isn't available in this menu, you can choose other, which goes to the periodic table. And then you can modify bond order, single, double, or triple. And then there is another option for adjusting hydrogen. And then by just clicking on the window, here you can create your molecule. The second menu is for transferring molecule to different location. Its symbol is like a hand, as you can see. So you can easily decide in which direction and how much you wanna transfer your molecule, up, down, or left or right. And then the third menu I'm going to talk a little bit about is energy minimization or optimization. There are several force fields available in Avogadro. Here I used universal force field and then the algorithm steepest descent. And then by choosing the start, your geometry will be optimized and it gets to its minimum energy, as you can see in the right figure. The second software is OpenBabel. OpenBabel is a chemical toolbox designed to speak the many language of chemical data. It's an open collaborative project allowing anyone to search, convert, analyze, or store data from molecular modeling, chemistry, solid state materials, biochemistry, or related areas. It is available for Windows, Linux, and Mac. And you can see here in the picture, it's from the OpenBabel website for downloading this software. Here you can see the OpenBabel interface. At the left, you can choose which format your file is. And the right, you can choose which format you are going to convert. So there are many formats available in the OpenBabel, and then by pressing just convert button, you can easily convert your file to the format that you desire. And there are some command lines for using in the HPC or high performance computer clusters. And the first one is standard conversion, OBabel, and the name of the file and format of it, and then -O means output, and then the file name, and then the output format that you need. Here is PDB. And there is another command which is useful for multiple input files that you want to convert in a batch format too. Here, as you can see, OBabel star.xyz or PDB. It means that convert all of the XYZ formats to the PDB format for me. And the last comment that I'm going to mention here is that molecules from multiple input files by different formats are normally combined in output file. As you can see, the OBabel, and then I have three files: XYZ format, SDF format, and CML format. And I want all of them to be SMI format. So I easily just execute this command in the CCAS or Photon, wherever that you want, and you have the OpenBabel executable file on it. And you can easily format your files through these commands. Thank you for your attention.
Okay, please join me in thanking Sarah. And presentation is open for discussion. If you have questions, either type or unmute the microphone and ask. Just in case no one asks, I have my question. And again, it could be tricky. Do not worry if you may or may not have the answer. So suppose you are a synthetic chemist who considers chemical reactions, and you want to model a reaction. You want to build a simulation cell that contains disconnected fragments, like two reactants that may or may not bind together. Is there a Babel command that will automatically separate disconnected fragments from one atomic model from one file into two files?
It should be, I think so, but I don't have the answer for it. Maybe I can search and
Okay.
let you know.
Yeah, if let's search and maybe discuss on the next lecture, because some of us may need it in the projects, and it is a really cool thing. More questions to Sarah? If no, please join me thanking her once again.
Thank you.
And the next, Sarah, please stop sharing, and Kaya, please start sharing. So next presenter is Cameroon Nahar Kaya. She will expand our knowledge about use of Avogadro software, and floor is yours.
Okay, so I will thank you, Professor. So using Avogadro software, I will show how to build atomic model, and after that I will show how to modify the angle, distance, and dihedral angle. So Sarah already just a minute. Sarah already explained that what is Avogadro and why we use that. It's the advanced molecular modeling software. So I don't why it's not working. Okay. So if we want to build an atomic model, first we need to open this Avogadro software. Obviously, first we need to install it. Then there is a option like a file, and you need to open a new command box. And after that, you obviously you need to save this file. It's a factor of safety. Otherwise, when you started to build an atomic model, maybe it will be gone somewhere else. Okay, so there is first you need to change the background color, because otherwise you will not able to see what you are doing and what you want to build. So I prefer to choose the change the background color. So there is an option view and the set background color, and after that you will able to change the background color of this. So there I want to show something like, okay, after changing the background color, we need to select something like there are go back. There is two options there, tool setting and display setting. When you click at display setting, you will able to see the display style. So there are several display types are there. So you need to select which one you want. So here I choose this two option, and suppose I need a I want the carbon atom, so I can select carbon. If you want to change the bond order, single, double, or triple, it's here. If you want to um, just you want to draw first only one atom, then just uncheck there. There is an option adjust hydrogen. If you do not uncheck that one, then it will be automatically create like an atom with carbon and hydrogen. So there is something I want to show that in video. So here, okay, so I display setting there, I select this toolbox, and after that there are so many options I told you before, and obviously you need to select a file, or sorry, save the file. Then after that, okay, so there I showed that if you want to uh, show the single bond, double bond, or triple bond, you can use this one. And there like, okay, So I draw atomic model here. There I uncheck hydrogen, so I can draw it easily. And after that, if I want to add hydrogen, suppose here in this section I add a hydrogen. I just draw this one to show you how to, if you do not uncheck, then what will be do. And there is something like that in so first I draw carbon, and then it's a ring. I choose a ring option, so and that's why it's like that. And after that I add hydrogen here. And there, this one is a draw tool. So using when you click this draw tool, after that you will be able to see this option. So okay, I already built an atomic model. Now it's turn to optimize the geometry. So when you click the there is extension, and there is option optimize geometry. When you click there, and you will able to see that it's looks nice. So that's why I did this. And if you want to see it's how it rotate and not, there is option for selection mode. And suppose you want to delete any atoms, so you need to click there. There is option like arrow, so click the arrow and select there, and after that you are able to uh, remove that atom. Okay. And another things, you can remove the atom, just select scroll down using your mouse, and type just press delete, then it will be delete automatically. There I draw methane, I guess. So I drew this one. Okay, I save this file. Okay, so this one, after build atomic model, I just want to show that how to modify angle, distance, and dihedral angle. So that's why I build another things, that is methane. So you need to see, there is a rule, there is option is like a ruler, so you need to click this one and see there, everything is written there. And after that you need to select two atoms. If you want to see a distance, then you need to select two atoms. If you want to see angle, you need to select three atoms. And if you want to see a dihedral angle, then you need to select four atoms. So it will show that when you build an atomic model, what's the angle of that. Still I'm not showing that how to modify those angles. So okay, I need to go to the next slide. Next, why it's not working. Okay, okay. There, wait, skip. It's not. Professor, my laptop stopped working. Just a minute. Two. Yep. So what the hell is going on? What the? It's not working. Okay.
Okay, but you can tell by words.
Okay. Because I don't know what happened. It was working. Okay. Yes, it was working, but now it's not. Okay, I already showed the atomic, how to draw the atomic model, and after that optimization, I showed these things. Then there is an option like I already showed this one also. And after that, there is like a, just Professor, there is an option I didn't show there. That's why I draw the. That's why I add the slide. There is an option in view. When you click view, there will be show an option to modify angle. Show the angle. So from that you can easily modify angle. Means like you want to change the angle. Then first you need to select uh, this angle. Using ruler you need to select the atoms. Then after that you need to select view, and there is optional like modify atomic angle, and there is option energy. So just suppose you use, I need 190-degree. So if you use that one, you can easily change the angle. And there is another option there. I modify. Okay, okay, I already, yes, it's here. So there it's written in a view. So you can change angle, bond, atom properties. You can change the angle properties here. So and after that there is another option like I need to go back there. This one just like a hand. So it's called manipulating tools. If you use that one, you can change the distance or angle manually. Yeah, like just select one atom and just pull it like this way. Then you can change the distance, or you can change the angle also. So we can do it manually, or we can change from the view option. There is a just you need to go there and change the angle. So when you change the angle and distance, dihedral angle automatically will be changed. I want to show those things in a video. I don't know why it's not working here, but I will send this. I already sent this one to professor. I hope it was working on that time, but now it's not working. So after doing all of these things, I want to show another thing that you need to what after build a atomic model, we need to we wanted to optimize our atomic model. So there is a option like E. It's written E. So it's a auto optimization tool. So when you click this one, you can able to see this things, and after that you can um, get a nice atomic model. So that's it. And after that is what you need to do. Uh, Everything is there in the picture, means in that video. So they you need to save the file. So there is a file option there, and so you need to click the file and save, or save as. Then you need to choose the option we want pdb or not. And there is another option is there, uh, like you if you want, you can save this things as an email. So we can do that. We don't need to um, take a screenshot, or if you want, you can take it. So that's it. Thank you.
Please join me thanking Kaya.
Yeah.
Okay, any quick questions?
Professor, I want to show those videos. I don't know why it's not working.
That's fine. Next time you will just share the link to YouTube, and I will show in the lab how to do it.
Okay, I will.
Such things. Do not worry. a quick question that do not worry if you do not know the answer.
Yep.
Suppose you are biochemist who needs to study docking of large bioactive species, which means like adsorption of one big biological molecule, like key and whole, putting it in the right place. So how would you move two fragments? Suppose you already built these two fragments. How would you move adsorbate to adsorbent, or like substrate to the place? How to move two molecules in respect to each other in Avogadro, if you have answer?
Because I never tried these things, but I draw like some huge, it's not a huge, like 2 or 3, then I add those things. So you are asking that how to move that one? Move. So there is an option like it's rotating. I forgot the name this, but there is option like it's red color sign. So if you click that one, and it's already started rotating. And there is other option for if you want to rotate, there is X, Y, Z. So it can be, maybe because I never tried this, so maybe it will work.
Okay. Okay.
Maybe.
We'll consider it in the next lab, but
Yes.
nothing wrong. You're in the right direction. Let's thank Kea once again.
Thank you.
And the last but not least, so Kea, please.
So I stopped here.
Stop sharing.
Yeah.
Is Omo Lola Enyo Dunmo. So Lola, would you please share your screen? And Lola will remind us how to use MOBAXTERM for connecting to remote servers, and how to measure distances with and visualize with JMO. So floor is yours.
Okay. Good morning, everyone. My name is Omolola Eniodumo. So I would be explaining the use of MOBAXTERM software and connecting to supercomputers and how to log into a Photon server. I'll also be speaking about the JMO for visualizing models. So first of all, you need to download the MOBAXTERM software. You just go into Google and type MOBAXTERM, and it takes you right here. After which you click on the download, which brings you to this page, and then you download this portable edition. It usually comes in as a compressed file that you have to extract the application that you need out of it. When you run the MOBAXTERM, it comes up like this, blank actually. So MOBAXTERM is typically used for remote computing, and in this context will be used for logging into a Photon server. So when the MOBAXTERM opens up like this, it usually has like multiple tabs right here, and this here is called the terminal. So here we're trying to log into a Photon server that's in Dr. Killin's name, and the MOBAXTERM uses the SSH client, which is used to operate network servers. So I'm not sure that my screen is very clear, but like, first of all, you put in this all the way to edu. It asks you for a password, which you input right here. It welcomes you to the Killin group server right here. And then you have to type in CD. Okay, so because like right here, I didn't put the space after the slash. That's why it's saying it's not a directory. So you type CD space slash to choose your directory, and then enter to click on, then you type in ls space slash to list out the content of the file. So it presents you with this right here. And then you need to choose a directory. You need to choose from this directory, which is called the Scratch 001. And then you need it to list the content. Now, when it lists the content, this is what you have right here. But you need to go further into the chem476 file. You need it to also list out the directory. That's why you have ls. And then when you go further, you need to access the chem676_2021 file. So after which you also want it to list out the content of this file. So it has all of these files with different people's names, with different things in it. So mine is Minati, and I'm just gonna do CD Minati because I want to access Minati. So in this Minati file, that it contains like a PDB. So what MOBAXTERM helps you to do in general, it helps you to access some certain functions and some certain file. So in this context, we're trying to access the JMO software. Now, the JMO software is a Java viewer for 3D chemical structures. It can view a variety of files in CIF, PDB, and it also has access to certain software like the GUS view. So here I've drawn this molecule from the GUS view and imported it into the JMO. So the JMO has like it has a couple of features. It has the file here if you want to save and open. It has the edit feature. It has the display button, the view, which shows you I mean, just in case you want to rotate the structure in different ways, you want to zoom in and zoom out, you want to look at your structure properly. That's what the view function right here does for you. So what I've tried to do here is to measure the distance between these two atoms. And that's why this measure ribbon is active here. So when you click on distance, it pops up this box. Now we know that distance is between two different points. So the software wants you to impute two different atoms to be able to measure the distance. If you do not, it's going to tell you that you need at least two different atoms to be able to specify the distance. Also right here, I tried to measure the angle. So it has a feature of measuring angle right here. And to measure an angle, you need to have like 3 different points to be able to measure an angle. So that's why it pops up with this box here. And if you do not impute 3 different, it's going to tell you that you need at least 3 different atoms to be able to measure the angle. So what I tried to do here was to measure the angle between here, here, and here, which is this 90 degrees. So that's the end of my presentation. Thank you for listening.
Okay, please join me in thanking Lola. Any quick questions? So I will ask questions maybe later, but some of class attendees need to run to different meeting. So we are already 1 minute past the schedule. So let me join, let me express gratefulness for presentations and discussions, both to class attendees and visitors. And everyone gets credit for this presentation, which is equivalent to like 20% of the final grade. So you are progressing well toward the end of the class. Okay, there is a little homework of who didn't submit it yet on making slide on definition of potential energy surfaces. Like majority of the class already did it. If you did not, you can do it by Tuesday. And other than that, there are no assignments. Please take rest and enjoy the weekend. Looking forward to see you next week, and thank you, everyone.
Thank you.
And everyone.
Yep. Meeting is done. Anyone is welcome. Everyone is welcome to disconnect. I'll stay here just to answer questions, if any.
Yeah. Excuse me, Professor. What was the question? Can you repeat the question for me that regarding the open bubble, please?
Please try to find a key, the option in the open bubble that will chop model onto several models. For example, if you have some simple example, CO, carbon monoxide, and H2O in the gases in the same model, how to create two files which will contain only one model per file, on one molecule per file.
Oh, okay.
It's just one letter in the command line.
Yes, maybe by grep.
No. It's specific line for the open bubble, and it makes it's not chopping the file on two pieces. It makes completely legitimate atomic model files that can be then loaded into the software. So it's just a little exploration that you may enjoy.
Oh, okay. Thank you.
Dr. Kellen?
Yes.
Excuse me. The question that you asked for Kea, it was about how to do kind of docking simulations, right?
Right. If we are studying binding of simple chemical molecules like gas to a surface, they will automatically rotate and come with the right binding spot. But if it is a big biological molecules, they have a lot of inertia, and it takes a long time on the atomic scale, like nanoseconds or milliseconds, to rotate and come with the right angle and right distance into the right spot. So the question was how to prepare for docking by placing substrate and the like two entities, host and guest, at the right angle and right orientation.
Can we do that on Gauss view also?
Yes, we can do it in both Gauss view and Avogadro. And it is just a little too much to squeeze into one hour presentation today.
Thank you.
And I believe it could be applicable to your research.
Yeah.
Okay. Any other questions, suggestions? Well, if no, I wish everyone to have not too many loads, not too many homeworks on the weekend from other classes, and hopefully accumulate energy for the next week.
Thank you very much.
Yeah. Thanks, Doctor.
Thank you.
Bye.
Have a nice day. Goodbye.
You too. Bye.